So we have here 2 glasses of 100% grape juice. And as you can see, we did this video just in time. We are going to use these glasses to see the concept of molarity and understand the concept of molarity. Watch what happens and tell me what happens if I just added more water to this one. What happened to the flavor of this grape juice? The flavor got weaker, and then I think you can see, yeah, it has gotten less colorful. The color has gotten less dark. Again, we can all see that it's been diluted. We'll get into dilutions next week, by the way. But so we've diluted this mixture, and we have made it less flavorful. So what you have to understand is, in chemistry, we use the term molarity to discuss or to describe how concentrated a solution is. So in chemistry, we use molarity as a way where we can put numbers behind the concentrations of solutions so that other scientists can work scientifically with our stuff, and we can as well. We don't have to use vague descriptors. Now, the flavor of this is less than the flavor of this, right? So this is more concentrated. This has a higher molarity. So molarity is a measure of how concentrated a solution is. The less concentrated it is, the lower the molarity. Now let's take a step back. Molarity measures the concentration of solutions. And if you remember back in August or September, we learned that a solution is a homogeneous mixture or homogeneous mixture of 2 or more chemicals that are mixed together, but they don't react with each other. So we now have a couple more definitions that we'll need to add to our repertoire. The first of which is a solute. Now, a solute is whatever there's less of in that mixture. That is called the solute. And the thing that is mixed with, which there is more of, is called the solvent. And so understand then that the solute is added to the solvent, and together they form a solution. So a solute is the chemical in a solution that there is less of. A solvent is the chemical in a solution that there is more of. And a solution is a homogeneous mixture of 2 or more chemicals that do not react with each other. And the solute is added to the solvent to make a solution. And remember, I'm an expressionist, not a realist with my art. Thank you. Thank you. So the solute is dissolved in the solvent to make the solution. And there's an easy trick to remember the definitions for these words, which is that solute has fewer letters in it than solvent does, and the solute is whatever there's less of. So hopefully that'll help you. It's worked for me. Back to the juices. Now, the grape juice is a mixture of whatever the grape part is plus water. So grape part is the solute, and the solvent is water. And what happened to the molarity when I added more water? The molarity went down when I added more water, meaning adding more solvent lowered the concentration, lowered the molarity. This tells us that mathematically there is an inverse relationship between molarity and the solvent. If we add more solute, then that will increase the concentration, or another way of thinking of that is that if we add more solute, then we've increased the molarity. And this tells us that mathematically there's a direct relationship between molarity and the amount of solute that you have present in the solution. One key point, though, is that rather than trying to keep track of how much solvent you keep adding, like if I added some and then I add some more water and then I add some more water, I don't want to keep track of how much solvent I've kept adding. What we've defined instead is, rather than looking at the amount of solvent that's used, we'll just take it all together and say, hey, this whole thing is the solution. So we're gonna the greater the solution is, that has an inverse relationship to the molarity. So we now have a ratio. How much solute we have relative to how big the solution as a whole is. If you have more solute in a certain amount of solution, you're going to have a higher concentration. But here we have the same amount of solute. Notice we didn't add more grape flavoring, we just added water. So we have the same amount of solute, but our solution's bigger. So it is less concentrated. It has a lower molarity. So we talked about the formula and the relationship between molarity and the amount of solute and the amount of the solution that are present. So we have this formula here, which you can see, where molarity is equal to the moles of solute divided by the liters of solution. Or you've seen this formula before. It's just capital M is equal to N over L. The N is lowercase. Couple of things here. One is that they will try to trick you, which means that I must try to trick you, because that's my job, is to prepare you for the tricksters in life that you'll come across later. When it's very common for people, when they talk about molarity, to just quickly start saying, well, molarity is moles per liter, moles per liter, moles per liter. But all of a sudden, you tend to forget, or you have a chance of forgetting, that it's moles of solute per liters of solution. And sometimes what happens is people think solutes and solvents, and so all of a sudden they see moles of solute over liters of solvent as a potential answer, which is wrong. And so be aware that that is on like AP tests. And since I'm here to prepare you for AP, it will be on our test. So be cognizant, even though you'll hear me say all the time, molarity is moles per liter, be aware in the back of your head that there's always moles of solute over liters of solution. Next, moles, it's odd. Yeah, they're moles, and the unit is MOL or MOLE. Both are the proper unit. But the variable for moles is N. So go figure. But as you can see, we have another M variable being used here. Capital M is molarity. We don't cover molality, which is something similar to molarity, but it's lowercase m, but then meters and miles, and there's a bunch of things that start with lowercase m, or variables with lowercase m, so I think they just didn't want to add another one when they did moles, so we have n. Just be aware of that. And then another trick, and that you will see commonly, like every probably 60% of the questions, will give you milliliters of solution, and you will have to convert milliliters to liters to get the proper molarity. So be aware of all of those things as you do the problems. Thank you.